Hello, and welcome to Advanced Magical Effects in Houdini. My name is Hunter Williams, and I'm a senior effects artist working in feature film and television projects. We'll be going over some bread and butter techniques that will allow us to produce art-directable and complicated effects quickly. We'll be focusing on solutions that enable us to iterate quickly and purposefully to address any of our own notes, as well as if we had any notes from a client or supervisor. So throughout the workshop, we're going to go through a couple of setups step by step. The main goal of the workshop, in my eyes, is to show you guys a lot of different concepts and a lot of different ways to mix and match these concepts. So I'll be going through a lot of the technical side of it step by step, and then kind of in a similar vein to if you had to do tech for a specific effect and then iterate them throughout the shots. The way that the workshop is going to be structured is by going through the setups and the concepts separately and building tech for an effect that we want to create, like an electricity or a lightning or a thruster kind of thing. And then we're going to actually go into each of the shots that I created, and I'll give you some project files to look through, but they're going to be pretty bare bones, just like the animation and the cameras. And I'll show you how I implemented that tech into those shots and made adjustments per shot and faced some different challenges, similar to kind of how it sometimes goes in production, and maybe also different ways that you could go about addressing notes, because that always happens. And a couple of things I want to promote and I want to talk about in this workshop is the idea of iterating quickly as one way of working. So there's a lot of different ways of approaching effects, and one of the things that I found success in personally is being able to have setups that are very flexible but also allow me to iterate quickly. Like I'm not a huge fan of waiting for large sims, and I know sometimes it's unavoidable, but for magic, at least as a base, starting out with something that is not very sim heavy, and if there is a sim, be very low quality and drives a bunch of other things. I think it's just a really good way of working, and it allows you to see your work and give yourself feedback, and that's like a big part of being an artist in production, is being able to give yourself feedback and work on things. And along with that is like this idea of art directability. Like, we want to make effects knowing that part of the process, unless you're working on your own project, but part of the process is inevitably I'm going to get a note from somebody, or I'm going to have my own critique, like I mentioned earlier, and we're going to want to make setups that are more flexible. And allow for me to, we don't want, all of these things to be dependent on each other to the degree where changing any one thing will change so much other stuff in your setup. So this idea of like art directability is another big theme throughout this workshop. Another thing is reference. I think every workshop at Rebelway goes into this, but really, when you're in a rut, or like if you're not, like, every artist has their days, and sometimes it is just really difficult to get the creative juices going and kind of grab onto something. And the best thing to do in that circumstance is lean on the reference that you had already researched. So we're going to look at a lot of reference. We're going to look at stuff from movies, from TV shows, from ArtStation, all that stuff, all that good stuff. Really anywhere. Like no place is not an acceptable place to get reference from. So even sometimes I'll film something on my phone for later. Like, especially like I feel like clouds. I do this a lot where I go outside and I'm like, oh man, that cloud's so fluffy and cool. I'm going to take a picture of that so that I have reference later. So there's like a lot of different reference that we're going to be using, and we'll be referring to them throughout the course. And especially with like natural phenomenon, like lightning and wind and rain and that kind of stuff. Like, that's really easy to get reference from. In fact, like stock websites, I'll show you later, but like, there's there's so many different stock footage websites that you can go to just to like find some good reference. And even I love looking for sound effects, because sometimes when I'm like, what would this sound like? Like especially these sci-fi things. Like I have a couple of different libraries of sound effects that I'll like just listen through sometimes, just to try to imagine, like, not necessarily close your eyes, but you just kind of sit back and listen to the audio and just kind of imagine the effect, and that can oftentimes give you ideas as well. So we're going to be building setups as if we're doing dev for an effect, and then we'll put them in the shots. So like this is kind of an advanced workshop in that we're going to be going over some advanced concepts, but also I would expect that if you're going to take this workshop, you'd be familiar with at least familiar with Vex. You would be familiar with the UI and general interface of Houdini, and somewhat familiar with rendering. We're going to go over some shading and everything, but the specifics of like saving out actual images and stuff we're probably not going to go over. I'll kind of just skip ahead in those moments to really pack in as much as I can about the techniques that I'm using. And for renders, I would say do whatever you can with the resources you have. We just kind of need something to work with in comp. Like I think there's a lot of really cool renders out there that you could use for the environment. Like I used Arnold for the environments here, and that's what I'll show. But Redshift's so fast, and you could try out Karma. You could try out Mantra for all the environment stuff, for the volumes and whatnot. So that, I would just try to see what you can get, and even if they're like really low sample, like they kind of look noisy and stuff, that's still perfectly fine. And the other thing that we'll go over briefly is wedging with PDG and top nets. This is not a top net course. I don't know very much about top nets. I know enough to get by, and that's pretty much all I want to share with you guys is enough top net stuff to wedge out some cool caches, bring them in, combine them. Like a lot of the magic stuff, like when you get into actual particles, I like, again, what I was talking about with iteration speed, I think it's important to iterate quickly on one, and then you could just wedge out 10 different seeds of it and combine them and get like a really nice, density of particles. Okay, so week 1, procedural concepts. We're going to go over, this is what I was talking about with the concepts. Like we're going to go over some really basic building block stuff, like norm age, normalization in general, vector rejection, which is going to be kind of cool, some modulo stuff, curve view, which is just like a UV for curves, but I'll go into it more. And then we're going to package a bunch of those things up, and I want to end the week with, I want to show an example of how easily you can layer these things to make some really cool stuff. And so we'll just go through like a quick example that you could follow along with, or you don't have to. You could just kind of make the tools that we make and then go off and do your own kind of thing. And just want to revisit this, like in terms of homework assignments and stuff like that for this course, since it is a little bit like the bar is a little bit higher in terms of people prerequisites and knowledge coming into the course, I would recommend that you create your own shot, and I would just focus on one shot throughout this course. Like I have like 6 shots in the promo. I would pick one of them, or pick another one that you just had thought of and you wanted. Like sometimes when I'm learning stuff, it's a great time to like really put my energy into a shot, because I know that I'm interested in both learning and also I want the end goal, which is that shot. And if you're not currently working in effects and you're trying to get into effects and learn, and you're a student, then it's even a better idea to create a shot that's separate from this, from the promo of this workshop, because I think it's something that I look for always in Reels, is that it is imperative that you have your own R&D in there that is outside of like a tutorial. Tutorials are great, but just copying what somebody is doing is doesn't really help you in creative problem solving. And creative problem solving is a really hard thing to teach. And I hope that throughout this workshop we can foster an environment in the Discord and stuff where we're creatively problem solving and trying to work out these problems in a creative way. And also these problems are creative. So it's not only technical stuff. It's going to be like, oh, does this, how does this look? Does the timing look correct? And do you really feel the impact of the animation? And it'll be a really nice collaborative environment. So, all right. So week 1. So week 2, we're going to go over the electricity tech. So this is where I'm going to actually go through step by step, like when we create the electricity and lightning. And I'll wrap it up into an HDA. I would recommend wrapping it up into an HDA because we're going to, essentially the way that the lightning works is that we're going to build a couple of building block HDAs, and then we're going to, with those HDAs, create our lightning look for that, specific lightning effect. So that way we can actually feed in however many strands we want if we're animating them or whatever, and it'll just like create all of these different lightning bolts with all of their tendrils and secondaries and tertiaries and all that kind of stuff automatically. So it's like a way of doing it for a large amount of bolts, a large amount of detail, but quickly, iteratively, and flexibly. So week 3, we're going to take a look at the environment and atmospherics. I'll go over a little bit more in terms of like creating a shot that you guys can work with throughout the rest of the workshop. So I really wouldn't worry about anything like, making your shot just yet. If you want to in week 1, then by all means, I would. But just so you know, this week will be kind of more focused on making a shot that is, it's going to be used for the rest of the week, or rest of the weeks. In week 4, we're going to go over the thruster tech, and we'll go over some of the shading that I did for the thrusters. A very important part of the thrusters is the composite, but we'll go over that in week 9, which is the compositing. You may actually, let me check real quick. Week 9, which is compositing. And then in week 5, we're going to go over the energy. I think really in this week, I wanted to focus on what the advect by volume stop does and ways we can kind of mess with it and get different looks. So this is going to be kind of piggybacking over some of the techniques that Jaden had gone over in the magic workshop. So if you haven't seen Jaden's magic workshop, I would go ahead and do that. And then we're going to go over some additional procedural approaches that maybe we don't have to simulate things, for certain looks. So just going to go over all those things, and then also some additional passes that we can give comp. And comp is one of those things where we should leverage it because it's a way we can really rapidly iterate because it's so fast and it's image based. So anything that doesn't really have to happen in 3D, I think like for when you're working in a department and you're handing it off to a different department, you should probably try to build as much as you can of the look into your render. But sometimes I'll just go back and forth between like Nuke and Houdini to figure out the look. And then once I've gotten the look, then you can bake it back into Houdini. So, like let's say you do like a volumetric element and you think, a certain density is correct, and then you render it. Maybe in comp you kind of play around with the opacity of it or some grades or something like that to figure out, maybe you want it to be a little bit lighter, like it doesn't really make sense with this comp. Then you can go back into Houdini, lower the density, tweak with it until you find like a good sweet spot, and then you render it out again, and that's what you hand off. So it's I think like the back and forth between Nuke and Houdini is going to be important. And then as you keep doing that, you can start to kind of understand like what you might want in Nuke, and you get a better idea. Like it's not always going to be like that. Like maybe at first when you're just starting out in effects, you do like 10 iterations, I don't know, something like that. And then as you get better at it, maybe it's only like a couple. So it's just a skill that you have to kind of like hone in, and we're all honing it in as we go. So it's just, a process of getting better. So week 6 is going to be about shot work. So I'm going to go through all the shots and really show like kind of where the setups are and how I put them in there, and maybe some like challenges that I had to come up with solutions for. There's certainly a lot of challenges with the lightning stuff and making it animate correctly in different situations. And then we'll talk about some ways of reducing render times, and some ways that we can go about thinking of rendering to get the most out of it, whatever resources we have. Let's see. Week 7, we're going to go over all the sparks, dust, AOVs. Sparks are going to be a big one. We're going to use the H19 sparks trail node, but we're also going to add additional features. And I'm going to show a bunch of different looks of sparks, because there's a million different sparks, and like, to be honest, sparks are one of those things where like you think they're simple, and then someone presents you a very specific look they want for their sparks, and then you have to, it's just tons of tweaking. Like all of Magic, I feel like, is just endless tweaking. But it's like you get the base look of the sparks and the behavior right, and then you just have to tweak until you find the actual look that you're going for. We're going to go over some more AOVs, and then we're going to, like I said, we're going to tweak a lot of the look. In week 8, we're going to do something a little bit different. I want to go over this kind of volumetric portal that's in the promo, and like volume deformation, because H19, they just introduced volume deformation. We're going to go over kind of what is happening under the hood, and then I'm going to show you the actual volume deformation workflow in H19. It's pretty cool, and it means that you can do, and we're going to wedge out a bunch of different clouds and like put them all together, and it'll be a pretty interesting week. And we'll also go over some rendering techniques and maybe some passes that we can generate. And in week 9, we're going to go over the compositing, and then if any other topics not covered at this point. So like if anything with the trees come up, I think that was like something people wanted to see. And any questions that people had, maybe someone brought in some reference that they wanted some advice with. That could be also a good week to do that. All right, cool. So I think without further ado, let's go into the first week. I'll see you then. All right, so let's get started with a couple of concepts over the next couple of videos. The first one is going to be normalization. And the first thing we're going to do is create a point with a random vector on it. We'll call this, we'll put it in velocity so we can visualize it pretty quickly. And we're going to increase the scale to something huge. And let me turn on make this a little bit bigger so we can all see it better. All right, so we've got a point with a random vector. What is normalization? Well, I'm sure you've used normalization before, just with normals, which is a vector that points perpendicular to a geometry surface. So our normals for the sphere would look something like that. But the word normal comes from, and what it really means in computer graphics is to make a vector a direction vector, meaning that it doesn't have really a magnitude. It is just pointing in a direction, and the unit length of that vector would be 1. So any of these vectors right here, if we measured the length of it, it would be 1. And I can show you that by just doing it. So you can see that the length is 1. Now if we added that to our random velocity vector, since we increased the magnitude of it in the attribute randomize, we can actually see that the length is something crazy, like 40.001. And I wanted to show you guys how to normalize this manually, because we're going to be using normalization throughout this entire workshop, just the concept of normalization and not necessarily just normalizing something. So this is the formula for normalization: x minus x min over x max minus x min. But in all of our cases, x min is 0. So it's actually x over x max. Or you could also write this as x over the length, the total length of x. So how does that translate into us getting the normalized vector of velocity? The first thing we're going to do is create the magnitude, or the length, whichever one. Those both mean the same thing. And then, in order to get the normalized version of it, we'll just cast it to the same velocity vector. All right, all you have to do is divide by length. This is the same thing as this. But the main difference is that we are storing our length in this float up here, this local variable float. And the reason why we're doing that is because now we can do whatever we want to the direction, and then all we have to do is multiply the normalized vector by its length again, and we get our old vector. So you can see disabling and re-enabling it does nothing. And this is really, really, really helpful, because we can change the direction of a vector or do whatever we want with the direction of the vector, and it won't necessarily change, what we're its total magnitude. So let's just quickly go over how to do this in VOPS. It's very easy. There is a length VOP node, and then all you have to do is divide this vector by its length, and you have now a normalized vector. And this we can store. Let's just call this normalized, and we'll call this one length. You could also do magnitude or something like that, length. And then we could just multiply this back, and you've got your setup again. And you could wrap this up into an HDA. All you got to do is subnet this out, and then maybe you want to go in here and reorganize a couple things. But this is as good as copyable. You can just copy this all over the place. It's fantastic, really. VOPS is the way to go if you like it. I personally really love doing things programmatically, like doing things through code if I can do it. But sometimes I'll scratch it out in code, and then I'll convert it to point VOPS later, so I could really make it
easily accessible to other people and easily accessible to HDAs. But yeah, I mean, anything that you see, like if you ever see a green word here, like normalize, chances are there's a VOP that is named the exact same thing. So it's pretty easy to convert this vex that we're doing in the workshop to VOPs. And in a lot of circumstances, I'll actually just go ahead and do that for you guys. So normalization, we now know the components of it, which is that you divide the vector or whatever you want to, or whatever variable that you want to normalize by the overall length of it. And we're going to be normalizing a lot of things that you can't use the normalize function to normalize. For example, let's say we have a noise that is across a curve, and we scale that curve up and down. Well, even if we sample that noise from a vector, from a float that, is going from 0 to 1 on that curve, so that would scale, but the amplitude will not scale. So we can normalize that amplitude over its total length. And I'll show you what that means later. You don't need to worry about that now, but just know that we're going to be using this technique in a lot of different areas, and being able to pinpoint it and say, okay, we are normalizing right now, can bring a lot of clarity to taking this technique and this setup and making additional variations of it, and using it in a lot of different effects that you do. Okay. The next thing we're going to talk about is age, and the reason we're talking about age is because and you guys probably already do a lot of these. This is definitely basic stuff that probably many of you guys already do. And some of the reasons why you should take a look at it now is because now I want to show you that normalization technique in action, and how you probably already used it. But here we have a bunch of points, and I've fitted a random life between 0.3 and 1.3. And this pop net only has pop wind, just to give you guys an example. And if I start it, nothing will happen, of course, because the starting point is 1,000. If I start it, it's going to go crazy, which is what we want. So each of these has a life, and it has an age. PopNet gives you age for free. And what were we talking about before about how normalization is literally just the float or component over its total length? Well, you can do that with age, because age, we have a life. Life is the total component of age for that particle. So we can take age and divide it by life, which is normalizing it, and we get this norm age attribute, which is a float that goes from 0 to 1 as the particle ages, and at 1 it'll die. All right, just to give you an idea of what that looks like, here we go. So now we've got this this normalized age attribute, and it can be incredibly useful for a variety of things, and we're going to use it a lot when we are doing this procedural motion setup for lightning. And just to give you guys an idea of how to do it in VOPs, again, it's very easy. Point VOP, age, we're going to divide this by life, and we'll tramp it. The color. So both doing the exact same thing, which is we're normalizing age divided by life. You've heard that a lot, you probably used it a lot, but now you know kind of the concept behind it, which is normalization. All right, so the next thing that I want to go over is, in the context of a line, what kind of attributes do we have at our disposal? So let's make a line here, some random line. Cool. Okay, so we've got a line, got a lot of points, and something that you may not know that exists, or you might, is that the resample node has this curve U attribute. And what is this curve U attribute? But it is a UV attribute that just follows the curve. Obviously, the V wouldn't exist because this is a one-dimensional object, a line, or two-dimensional. But it goes from 0 to 1 along the curve. So let's visualize that. All right, let me go ahead and up the width of this guy. All right, so you can see it goes from 0 to 1 along the curve. So what is that? That is, each point knows where it is, measures up to that point, and then normalizes that measurement over the curve. So just to give you an idea of how we can do that, if we have this dist attribute and we measure how the perimeter of this curve, and promote that, then we can do the exact same thing by using our normalization technique, which is that we do at, let's say, norm length equals dist over perimeter. And there you go. It does the exact same thing. So the idea of getting the normalized attribute for the length of this curve is the same thing as dropping down a resample to get curve U. There's actually one other method that I would suggest using more than this resample method, because the resampling, while most of the time, if you have everything unchecked, it will, here, let me just get a couple more points on here before I do that. While most of the time, if you leave everything unchecked, it won't change the point count. Because you still have this level of detail, it sometimes still can mess with the amount of points. So I actually don't suggest using resample just to get curve U. Another way you can, or this method. This method is just, just for display method, just for me to show you guys how it works. But there's another method that I would suggest using more, which is to use the UV texture node, and you can just change texture type to arc length spline and change it to point. And then I like to add a point wrangle underneath and add curve U equals at uv.x. And you got your curve U here. And this is just, I think, the lightest way you could do it, other than resampling, but resampling sometimes changes your point order or point count, so I would highly recommend not doing that if you want to keep everything constant. I've had situations where I used the resample to get the curve U, and then way later down the line, there was some really weird artifacting going on, and it was because my point count was changing, and I didn't even realize it. So I would not use resample just to get curve U. If you are resampling, then by all means use this curve U option. It's something that you can get for free and not have to really mess with anything. But something that you'll see in a lot of our setups is that I'm actually going to package this up. So I'll attribute delete. And remember, we want to make sure that we are creating setups that other people could use. And look, chances are when you revisit these tools, you're going to have to jog your memory. You're not going to remember everything that you did or every attribute that you created. So we're going to try to employ a couple of really nice techniques to keep organized. And always whenever we are creating an HDA, we want to, if we create these attributes that only the HDA is going to use, we want to clean that up afterwards. Because when you're storing, I don't know, hundreds of thousands of points, 200,000 points, a couple million, whatever amount you're storing, the thing that increases file size the most is the amount of attributes that you have on your points. So we really want to try to reduce the amount of attributes that we're storing at the end of our HDA. And some attributes are good. Some attributes you might want to keep, especially we'll get into the Lightning setup for the rendering. We're going to want to keep a lot of attributes actually just for doing some shading, doing some comping, some AOVs and passes. But just remember that anytime that we create local attributes that we know we're not going to need later, we should actually just delete them afterwards. So in this case, I'm actually just going to make a little tiny HDA where I create this UV attribute. I'm going to do underscore UV because they may already have a UV going into this that we don't want to mess with. So if we create underscore UV, that's most likely not going to be utilized at that moment on the input. So underscore UV, we're going to grab that UV attribute, put it into curve U. And then we're going to delete all of our underscore attributes. And that's another really good reason to use this underscore, is that you can just do underscore star, and it's great. So now we're left with this curve view, which is awesome. And we can just package that up, call this curve view. And if you don't have this already at home, I would just go ahead and right-click, create digital asset, and that way you can just drop it down whenever you want, and you get your curve view attribute. All right, now that we've done our curve view setup, let's go ahead and talk about how to make a line animate. There's a lot of different ways to do it, but I'm going to show you a way that I use all the time because we're going to do it with attributes instead of like carving, for example, and baking it into the geometry, whenever you animate it. All right, an object level node called anim, and let's dive in. Let's get our curve in there. All right, and then we just created that curve view digital asset, so we're going to drop that down. If I can find it. All right, so now if we visualize our curve view, we've got nice ramp from 0 to 1, which is what we want. Okay, so the first thing we're going to do is simulate. We need to give it some kind of like age and life attribute. So maybe it comes out of a pop solver, and that'll come with an age and life attribute. But in this case, since we just have one strand, or one line, and we're not doing anything fancy with it, we're just going to create our own. And you can do this with point wrangle or a VOP. And we're just going to do at age equals age, and at life equals life. All right. And for the sake of this lesson, I'm going to animate age from 0 to 1. And I'm just going to have life as 1. And the first thing we're going to do is do just a very simple version of this, which just to prove, or just to show the point, we're going to drop in another point wrangle, and I'll briefly show you how to do it with VOPs, but at some point I'm going to stop doing that, and pretty much everything that exists in a wrangle you can find in VOPs, but for some things I just prefer doing it in a wrangle. First thing we're going to do is normalize our age attribute. And then we're going to create an attribute. You can name this whatever you want. For the sake of simplicity, I like to call it anim. And we're going to fit our curve view 0 to 1 attribute along the strand. We're going to fit that between the norm age minus some width attribute that we'll create in a second. With norm age, and from 1 to 0. So right now, let's go ahead and make just a temporary width attribute of 0.1. So what we're saying is that there's going to be a width to this line. We're going to fit curve view 0 to 1 age. As age is going up, the maximum that this attribute will be visible is going to be at norm age. And then, hold on a second. And then it's going to fall off to norm age minus width. So what we're going to see is 10% of our line is going to light up at any point in time. It's going to travel in the direction of curve view, meeting essentially where age intersects curve view. So if age is 0.3, then it'll be at the 0.3 along curve view. So let's visualize this real quick. So you can see that it just travels upwards, and that fade is 10% of the line. And you might be at, okay, so that's great. We can get the line to grow, but how could we get just like one little tiny portion of the line going at once? So all we have to do is ramp anim, because it's 0 to 1 attribute. We don't need to do any fitting. And something I always like to do is personal preference. I love B-spline. It's very smooth, and you don't really have to try very hard to make it smooth. Sometimes with like Catmull ROM, I still get some like weird kinks and stuff, especially for these like very broad stroke curves. So now you can see it's just a little part of the line that's traveling, which is awesome. That's exactly what we want. Now, what if, like, I like how this is moving. It's cool. But what if we wanted it to, I don't know, speed up all of a sudden? So it starts slow, then speeds up. Well, all we have to do is remap age. So age, or remap norm age. So let's go ahead and try that. I'm just going to cast it to the same variable because I don't want to change everything, but call it age, norm age. And we need to normalize age. Just, I wanted to mention this. We need to normalize age so that we can do all of these ramps. It needs to pretty much be in the same range as curve U, or else this isn't going to work. Or you'd have to do some significant, fitting in this. But usually I like to work with norm age just because it's a lot easier to work with. But I'll show you some techniques that you can use later to dial it in more specifically, because norm age is more of a percentage-based system where you're working with, like over the course of its age in the last 30%, I want it to speed up or something. But we could be more specific than that, and I'll show you how to do it. But for now, let's try messing with this age parameter where we're remapping how age is interpreted. So now you can see it starts really fast and then slows down towards the end. Let's try the other way. Have it start really fast or start really slow and then speed up gradually. And the beauty of this system is that, let's say you have a bunch of different lines being generated, or a bunch of different points, and you generate lines based off of those points, but those points have age and life, then all of this stuff is going to happen procedurally. So this is what I like to refer to as procedural motion, where you have animation being piloted procedurally by a source. And I'll show you what I mean by that in a minute. Okay, so this is cool and certainly very useful. But what if we wanted something a little bit more complicated? Like, let's say, this is a lightning bolt. We're going to be looking at lightning bolts throughout this. But what if we wanted, at the very end of that lightning bolt travel, it lights up the whole strand, because lightning tends to have some behaviors where it looks as though like the electricity is traveling, and then once it makes contact with whatever it's going to make contact with, the whole bolt just glows really, really bright. So we can actually build that into this system where at the very end of this, once this kind of reaches the end of the strand, we can have it light up the whole strand. And it's not too terribly hard to do. I can show you one way you could do it, could approach it. We'll call it an event. And we'll say that if our anim attribute is greater than 0.8, or let's call it 0.9. And so in other words, if it's bright and curve U, so the UVs of the strand, so distance along the strand is, greater than 0.8 as well, or 9. Let's say 8. Okay. So if it is bright, if it's currently visible, and it's towards the end of the strand, let's say that a connection's been made. I at connection equals 1. So we're just saying at some point, only a few of these points will have it, but we can check it out. Actually, let's check connection, curve view, and anim. All right. So as this thing animates, it's moving, curve view. We're going to be looking, so we want, our condition is that it has to be over like 0.8 or something, right? So as it gets further down, you can see now those ones are starting to change. Before 0.8, they weren't. And then now that connection is being made. It's saying, hey, the electricity has reached towards the end of its strand and it's lit up. So we've hit something. We are at the end of the strand. We're at the end of the path. Great. So how are we going to light up the strand? Well, we could do it a couple different ways, but the easiest is just, let's promote this the connection to a primitive. And let's make it max. And then let's copy and paste this and then promote it back. Primitive to point, call it max. So you can see connection's not been made. It's traveling, traveling, traveling. And then right once it hits 0.8, everything turns to 1. That's cool. So the only thing we need to do now is say that if connection equals 1, let's force anim to equal 1 as well. So now if we check out anim, you see it's traveling, 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 and then right at the end it snaps, lights up real big. And if we want to do something special later in shading, then we have this connection attribute that will trigger whenever that event has happened. So not only do we have the anim, we also have this connection. You don't even have to really mess with the anim if you're going to do something in shading later, because we can always just use connection directly. And let's also just make sure we're being neat with our networks. When we're doing things like this, it's really ideal if you label everything. So maybe I do connection to anim here. And just to kind of show you guys, I guess, for this, how to do this with FOPs. This could be pretty easy. So a couple things we're going to need to bring in is age in life. I know there's age down in the main block here, but you know, if we're going to be doing a lot of stuff without this, then you know, kind of think it's a little clearer to whoever is looking through your scene. You know, that's one of the things that you're going to have to remember, is that when you're doing these magical effects, especially if it's for character, or if it's for you know, a character that specifically that is throughout the film or the show, these setups are going to be used a lot. And if you're deving this stuff, you know, you may even want to use it later. You may want to save it for later. That's one of the benefits of Houdini, is that you can keep reusing these setups, build on them, make them better. So making it easy to read is always a good thing. And later on, I'll show you a couple techniques that I use to try to keep things nice and neat. But let's get back to this. So we want to make norm age first. So it's age divided by life. We'll call this norm age. And we'll add a ramp to that. Okay. Ramp age. And then let's make this anim stuff. We also want to bring in curve view. Add a constant, subtract. Actually, let's make this a parameter. Call this width. So we want to subtract this from norm age, and we'll get source min. Source max will be norm age. Sometimes I like to just add some nulls around, make things nice and neat. That does not look very neat, does it? All right, we'll say that that looks neat. And then we'll ramp that. Call this anim. Spline ramp. Line export. Anim. All right. Pretty simple setup. Just to show you kind of how you might approach this. In a VOP. Make some of that stuff that we've done before. There we go. All right, there you go. So it's possible in both ways. All this stuff is pretty self-explanatory for getting into VOPs. I think this is a little bit more readable for my taste, but depending on the person. Also, the thing about VOPs, again, like I said before, is that all this stuff is packageable. So you could then wrap this up into an HDA, which would be pretty nice. So maybe doing it in VOPs is not a bad idea. In fact, actually, I just want to quickly show you, mention that you have this one part right here that's glowing. You could make it like a line of them if you wanted to pretty easily. For example, I could make, let me just reset this. I could make a bunch of little jagged kind of edges and stuff. To get kind of nice frequency pattern that travels. In fact, you could also maybe extend the width a little bit, and there you go. You got three of them that are kind of chasing each other. So like I said, you can make all these really cool effects with it. And I'll show you ways that you can make it loop and all that kind of stuff in a second. But this is kind of the base system. And you may already do this stuff, but it's nice to be able to kind of pinpoint what the base system is and be a little bit more simple. Sometimes these kinds of systems can get kind of complicated and maybe more complicated than they need to be. And you can always do a bunch of stuff. Like sometimes someone might drop down a carve and try to hand animate this. Maybe like that, and then you animate this and this together. Maybe it's this. Maybe do something like that. I try to avoid this as much as possible because I really like to work with the line as a whole until I absolutely need to actually trim off the edges. And in some cases, you don't even have to trim off the edges if you're rendering lines with width, you could just have the width be 0, and that way you could make a really nice ramping effect to where it's not so sudden. All right, let's talk about the modulo operator. What is the modulo operator? Modulo operator is a percent sign. And what it can mean, it's a division operator that returns the remainder. So let's make one up. Let's say at foo equals 2 modulo 1. Well, 2 divided by 1 equals 0. So what would this return? I would expect it would return 0. But let's say we have, let's do 2.5. 2.5 modulo 1, well, 2.5 divided by 1 is 2 with a remainder of 0.5. So it should return 0.5. Okay. So why is this useful? Well, it's useful in a lot of various ways. One of the ways that we could use it, and one of the ways that I often use it, is if I want to see if something is divisible by something else. Like for example, if, I could get, if at time modulo 3 equals 0. So what this is going to do is it's going to say if the time is divisible by 3 seconds, so every 3 seconds it's going to equal 0, and then it's going to do some action. So as we scrub through, you'll see 1 appears here at 10:09, and then 3 seconds later, 72 frames later, bam, 181. So that's one way of using it. Another way of using it is to pulse. If I did at foo equals at time modulo 1, then what we're going to end up getting is essentially a ramp that goes from 0 to 1 over the course of 1 second. So you can see it goes all the way up to 0.9, pretty close to 1, and then resets to 0. So it'll just keep going up and down, up and down, up and down. Okay, so that's cool. But another way we can do it, we can have this, we could do something crazy. We could do like some flickering effects. So let's do at foo, or let's do if time modulo 0.1 is less than 0.03, I at foo equals 1. So this will just flicker, on and off, on and off, on and off, on and off. Because essentially it's saying if time divided by 0.1, if the remainder of that is less than 0.03, which it would happen quite often, then foo is going to equal 1. Okay, so you could get some cool flickering effects. You could get some cool ramping effects. Let's make it a little bit easier to control. So let's make a pulse fit at time modulo 3. So that's every 3 seconds. It's going to be ramping from 0 to 1. Or it's going to be ramping actually from 0 to 3 because, 2.9, or let's say, 5.9 modulo 3. So 5.9 divided by 3 is going to be 1, remainder 2.9. So 0. So we have to remap that remainder from 0 to 3 back to 0 to 1. So now this is going to pulse every 3 seconds, but from 0 to 1, not 0 to 3, which is nice. And you could just add a little float up here and say float time increment equals that, and then put time inc here, time inc here. Oops. So now you can, just put whatever duration you want, and it will just remap that duration from 0 to 1. That's neat. Just another thing to keep in mind. We're going to use it a couple times later for various things, but it's a really useful operator. There's plenty of other uses for it, and I would try to mess around with it and play with it and see, different times you could use it. And I think in VOPS they got the same one, so let's check it out. Yep, modulo right here. So it's going to be number modulo second input. So you might need to fit, let's say, constant. So, whatever, foo modulo constant, and remap that 0 to constant, 0 to 1. So this would be the same thing. Every 3 seconds, it'll reset. Yep. All right. Now you know modulo. All right. So now let's talk about twisting a curves around another curve. And this is useful for so many different effects. Like a laser beam or something, you might want to have those like twister guys going around, and it's an incredibly useful effect to know how to do. And it can be a little bit challenging to think about at first, but not too bad. Let me grab my curve. Okay. So we have a curve. I want to actually resample this a bit more. All right. So the first thing I want to do is tell you about a node that is really awesome. And I don't know when it was added, but it seems like it was added relatively recently, which is the oriental on curve. And what oriental on curve can do, these output attributes are, it's kind of like what the polyframe does, but the polyframe is kind of weird in some situations. But this has pretty much always been very accurate and gives me the correct values that I want. And let me just make some visualizers for these attributes. Normal I have. Okay, so normal goes down the barrel. Out goes one direction, and up is perpendicular to both of those. And we'll need all of these attributes. Well, actually, we'll really only need 2 of them. So this is going to get a little bit more complicated. We're going to use quaternions, but if you don't know what quaternions are, suffice it to say that they're a very stable way of rotating vectors that doesn't have many of the pitfalls of doing it with regular Euler methods, which can cause gimbal lock and a couple other various nasty side effects. So I'm going to show you this. I would recommend looking into what a quaternion is if you don't already know. There are a couple Rebelway courses that go over this, but they're really useful, and I'll show you one method of using them right now. So the first thing I'm going to do is just create a couple variables. Call this out. And we're going to create an angle, and this is in radians. So I think radians is 0 to 2 or something. 6.2. So in one circle, there's 6.2 radians. So we're going to create a rotation that goes along curve U from 0 to whatever we want. And this is going to be the amount of like twist there is along the curve. So we'll just make this twist amount. And you'll see what I mean in a second. So we're going to create a quaternion. Call this our rotate quaternion. And the angle is in radians, so we're going to put our angle in there. And we're going to rotate our along our normal axis. So that's the ones going down the pipe right here. So our axis is the direction of the curve. And the vector that we want to rotate is out. So we want to, I mean, you could do any one of these, but I'm just going to pick one that's going away from the line. And there's a function called qRotate that rotates a vector by a quaternion, so we want to rotate out by rotate. So now, interesting. Oh yeah. So now, when we increase this twist amount, nothing will happen. Not always bad to check the documentation. Okay, so I just got the order wrong. It's quaternion and then vector, so it'd be rotate and then out. Okay, so now you can see that it's rotating. If I increase this, it rotates even more. Eventually we get this cool little frequency pattern. So we're going to say this is rotate out. So now, if let's say we wanted to, let's duplicate this for a second. Let's say we wanted to offset this and have this travel along the strand. Well, the place that we could do it is with this curve U. So let's actually make an attribute called curve U and make it at curve U plus offset. Let's replace this guy here. So now you can see that we can move all of our rotations, but as you might notice, it's leaving a trail of unrotated stuff behind, which is undesirable. So what could we do to avoid that? We can use that modulus function that we were just talking about, where we do curve U mod 1.01. The only reason I'm doing 1.01 is it will help avoid any kind of issues with overlapping. Here, I'll show you what that looks like. Just 1. Then when we offset this, it might be more visible later, but you might see like a little ridge that appears somewhere. And sometimes what I just do when I see that is just add 0.01. And it usually fixes it. Okay. So now we've got a way of animating our twisting. So you might be thinking, okay, but what about actually twisting the line? Well, that's going to be pretty easy. Duplicate this out. After we have out, we're just going to say plus equals out times some multiplier that we want to create. So now we have it twisting around. Very cool. So let's have a little bit of fun with this. Let's create a for each loop for a number. Something I like to do immediately is add this, call this get info, add a spare parameter. Oops. Yeah, spare input, and then let's just create a iteration parameter. It's just a lot easier to see. So we can put this guy here, do detail, -1, iteration, the 0th element. So now we're at single pass. We go to single pass 4, and we should see 4. Okay, perfect. So now let's take our move position guy, and let's copy this. And let's just paste this in our offset, and let's say times 0.5 or 0.05. And let's add time divided by 20. So it's going to move really slowly. Yep. And there you go, you got a little braid. And it's moving around. And we can move this curve anywhere we want. Well, let's Move this anywhere we want. And everything tracks. Awesome. Very cool. All right. Let's do something a little bit more interesting. I'm going to take the amount down by a lot. And then I'm going to use the create age that we had before. So just age in life. And I'm going to go back to our anim geometry and grab our animate. Awesome. Now we've got this really cool spiraling animation. Let's do a couple things to make this a little bit nicer. Something that I find a lot with these kind of traveling effects is that the leading edge is much brighter than everything else. So let's make that happen. Something like this. All right, cool. Let's make the width a little bit longer. Cool. Let's increase this out a bit. Cool. And it looks cool, but it's also just very uniform. So something else we could do. Let's add a strand ID. All right, so let's add a strand ID that's just the iteration number. And then let's copy this over. Get rid of that guy. Give this guy a strand iteration, a strand ID of 0. So we're adding the original strand back in. So it's, you know, a couple strands orbiting around one strand. And in this in this age, let's just add a fit, and let's fit strand ID between 0 and however many iterations we have, which is 3. Between 0 and 2, because it's 0, 1, 2. Actually, no, it would be, yeah, it would be 0, 1, 2, and 3, because we have our original strand right here. So it'd be 0 and 3. And let's remap that to negative point, some random number. We could do 0.03 to 0.03. So now it's going to be adding age, or adding to age at a random amount between negative 0.03 and 0.3, depending on the strand ID. Cool. So now we have a little bit more variation. But you might be seeing that there's also some issues with the looping stuff. So to counter that, what we could also do is, as a quick solution, is clamp our age. Because what's happening is it's essentially at the end, it's adding 0.03, which is then feeding back in. And at the beginning, it's minus 0.3, which is then feeding back in as well. So now I've got a nice animation. Cool. And you can do other things, like you could have, this central line have a different width or length as the outer lines. You could completely separate the two systems, where you put one over here. And that way you could do very special things to the center line, and then do some kind of interesting things to the outer lines. There's a lot of really interesting, cool things you could do. I would experiment around as much as possible. And then if you want, something we're going to talk about and we're going to be using quite a bit is, not many people are aware of this, but there's a way to visualize width in the viewport using shade open curves. And the thing about that, though, is that you have to enable it in two spots, and if it's not enabled in both of them, then it's not going to work. First, it has to be enabled in the geometry tab of your display options, shade open curves. And then it also has to be enabled on the object level under MISC, shade open curves and viewport. Right now I don't have a width attribute, so it's not going to really do much. But let's say I have at anim equals, or no, let's say at width, and it recognizes the width attribute, equals at anim. So now you got this like really weird spiraling like ribbon thing. So I would just multiply that down quite a bit. Maybe a little bit more. And like everything, you could remap this, so you could have it be very, very thick up the top and then spiral down pretty quickly thereafter. But have fun with it. I would build this setup and then try to see what you can implement. Maybe there's something cool you could do with the modulus and the twirl around strand stuff. A lot of different methods, a lot of different things you could try to create really unique looks. A lot of this stuff, like all this stuff that I'm teaching now, are all Lego bricks that you could use to create your own, effect later. I would try to layers. I mean, magic is like layering. You want to layer as much as possible, make really good, unique, elements, but have them come together in some way. And this is a really good one to do for lines specifically. All right, let's talk about vector projection. Vector projection is something that we use all the time, and is a really cool trick to have in the back pocket. It's a little bit more mathematical, but this is pretty much about as mathy as we're going to get in this workshop. And I just want to explain the math part of it, so you know that this is not a technique that I just came up with in Houdini just by trial and error. This is actually something that you guys can look for, these type of techniques in everyday math. And if you're just kind of looking things up, you might come across a formula that you might want to add to your arsenal, and it's incredibly worthwhile to do so. And this specific technique is really useful for being able to get your vectors to align without diminishing one of the vectors kind of meaning. So let me try to rephrase this. So let's say we have a noise represented by our red vector, and we have our tangent vector, which is going down the barrel of this line. But this noise is not perpendicular to this vector right here, to this barrel vector, this tangent vector, or the blue vector. And we want to make all of these red vectors point perpendicular, from this blue vector. But we also want it to still be noise. We want it to still be random. Well, we can actually use vector projection. So let me just quickly explain what vector projection is, and then I'll revisit how we can use it in this specific circumstance. So vector projection is kind of exactly what it sounds like. We're going to metaphorically shine a light on vector A and get the shadow of that on vector B. So it may not be the exact same vector, but it's going to be pointing in the same direction, and it might just be a different magnitude, because essentially what we're doing is we're getting any bit of vector B that's in vector A, we're extracting that. So you can see over here, we have a good example of how this is going to be a much shorter vector than vector B, but it is still going to be pointing in that direction. And if, for instance, we then subtracted this vector and this new projected vector, then we would get the remaining vector, which is essentially any bit of this vector that's pointing, that is not pointing in this direction. So in this case, it would be something that looks like that. The formula for this, and I'm gonna read it to you how I would read it, and then we can translate this into VOPs just by how I'm gonna read it. Because sometimes I feel like when I'm looking at these formulas, it's really hard to kind of figure out what exactly goes where. But if I read it to myself, or I find an explanation of it in a book or in a passage, then it's a lot easier for me to figure out, okay, what might I do in VOPs. So this is the projection of A onto B equals the dot product between B and A divided by the length of B squared times B. And we're gonna come back to this formula in a few minutes when we're building this in VOPs. But just to kind of elaborate on what we're going to see, is we're going to see actually a bunch of vectors that are pointing now in the direction of our tangent. And the reason why we're going to see this is because we're projecting this red vector onto the blue vector. But like I said earlier, we can actually then take this original noise vector and subtract this new projected vector from it. And then we're going to see that that resulting vector is pointing away from the line at all points. All right, so let's go ahead and jump into Houdini and implement this formula here. First thing we're going to do is replicate the scenario that we had created on the whiteboard. So I've got a line, I've resampled it a bit, and I've oriented a long curve, and I created this vector tangent. So if we view tangent, we can see that it's pointing in the direction of the line, so that's all great. Let's go ahead and drop down a point VOP, and let's create some noise. And refit this. It's going to be a 3D noise, and negative 0.5 to 0.5, negative 1 to 1. So now, and let's just visualize this with normal, is we have just some random vectors pointing all over the place on our line. And we want to first project these onto this tangent vector. So let's go ahead and take one more look at our formula and figure out which of the terms each of these vectors are going to be. So let's go here. So we want to project A onto B. So A is going to be our noise, and B is going to be our tangent. But I actually want to do something a little bit better, and I want to color these so that let's say, just for the sake of this, let's bind export A, and let's bind export B as well. Oops. So the first one, tan, our tan is going to be B, so it's going to be blue. Let's take tan, put it over here, clear these guys out, and then our noise is going to be A. So let's go ahead and visualize both of these, A and B. And let's make sure these are set correctly. Marker, vector, and what color was A again? It was red. And B, we're going to do marker, vector is going to be blue. Let's make it something like that. All right. And then I'm just going to drop and add down and get rid of this line so we can kind of see a little bit better both of these. And I might even just scale down my vectors a bit in the viewport just so that we can see what's going on. All right. Cool. So we have accurately replicated kind of what our situation was on the whiteboard. And now we can just go and do the rest of the formula. So let's drop a null here, make this, just call this vector, vector A, drop another null, vector B. All right. So first we got to do a dot product of B and A. So that's going to be easy. Dot product of A and B. That's going to be over the length of B squared. So let's get this length of B, and then we're gonna square that. So drop down to power, bit 2, and then we are going to divide these two. So divide, and this is going to be a float coming out because of dot product and length that converts these vectors to floats. And then we're going to multiply this by B. So we're going to take B here, multiply B, this is a vector, and then we're going to multiply that by a float. So we're going to get a vector back. So this should be our projected vector. So let's check it out. Sweet. That looks about right because now everything's in line with our tangent vector, or our vector B. And if I got rid of the B here, you can see that all of these have values. Some are just much smaller than others because some of them are pointing directly out or even backwards, so it wouldn't have a shadow, so to speak, on that vector. So what can we do with this? Let's do that thing we talked about where we subtracted it. But first, I just want to go ahead and put this in a subnet and organize this just a bit. Get rid of this output, this guy. Cool. All right. So then we get our projected vector. Cool. And now let's take our initial noise and subtract our projected vector from it and grab the end. And here we go. Now we've got this noise, and you can see that it's pointing in any direction really, just not in the direction of our tangent vector. So this is what I was talking about. And let me just make these vectors a little bit more pronounced. Where now we have this noise that's perpendicular to our original tangent vector that was pointing down the barrel of the line, which we can see here is B. And let me just go ahead and grab B. And we didn't have to do anything weird by generating like a 1D noise or something. We got this all just by using our regular noise and then this vector projection. And so this is vector projection right here that we have in the subnet. But there's kind of a term for this subtraction, which is vector rejection. So now let's go ahead and just apply some noise to this line, because you can see kind of some of the benefits to this. And let's increase the point count by a lot. Get rid of our visualizers, and we're just going to add this to our position. And here we go. So now we've got this nice natural noise. I mean, you're gonna have to tune in the parameters a little bit. That runs, perpendicular to the line. If we didn't do this projection, then we'll get some kind of weird. Hold on one second. If we didn't do this projection, then we might get some kinks that arise, and if we push it even more, then it's actually going to do these loop-de-loops, which are kind of undesirable, especially for lightning, when we're trying to kind of control electricity, when we're kind of control all of this stuff a little bit more. And lightning and electricity does have these loops, but we want them to happen when we want it, and not because just the noise kind of gives us that. We really only want to get this noise that's going outwards from the direction of the line. Cool. So the last thing I want to do in this lesson is wrap this up into an HDA, and it doesn't have to be anything crazy. We're going to make this vector, we're going to call this vector align, but I'm going to actually just call it align test because I've already made one. And go to main, vector align, and save it in your directory of choice. Let's see. So I'll save mine in here. Oops. And hit create. Then it's just a matter of going in the type properties and making sure everything is labeled correctly. All your inputs, we can call this. And for the, we're not going to, this formula and stuff, we're not going to revisit that ever. We may forget it. You may forget it. So we don't want to create input names that are going to confuse us later. So that's the reason I'm calling this vector align, because it's kind of what it's doing, and for all intents and purposes, that's how we're going to use it. Just you can remember that it's vector projection, but if you hand this off to somebody, they may not know what it's kind of supposed to be doing, and we don't want to hide that behind any kind of fancy terms or anything. So I'm going to call it vector align, and for our inputs, I'm going to name tan is going to be our target, and I'll call shift our just we'll call this just like input vector. And then our shift, this output is fine. It doesn't really matter. Cool. Hit apply, accept, and save node type, match current definition, and we're off to the races. So let's just quickly drop this into another setup just to kind of show you how kind of versatile this can be. Let's just grab a pig head, and I want to add some noise that's going outwards from the pig head. So I'll just grab an A noise, fit this. Oops, grab that, fit this, and I'll vector, well actually, let's create our normals. And let's vector align this with our normals. And let's add this to our position. So now we get this noise that's going outwards from the actual pig head itself. And this is the kind of flexibility that we are looking for in our setups. And some of the tools that we want to make are going to be these very basic tools. And we're not going to really, these kind of building blocks. And this is also the reason why doing things in VOPs can be pretty nice. There are ways, again, to add custom functions to VEX so that you can just use that function, but it's a lot easier, and people it's more widely known how to make HDAs and work with HDAs, and you get it in the tab menu, and you don't know kind of what environment you're going to be in whenever you're doing work. Like, for example, you might be at a studio, and it's pretty easy, I would say, at most studios to make HDAs for yourself, like user HDAs. So this is just a really good way to have a handy tool in your back pocket. And we're going to be using it throughout the next few weeks. Awesome. All right. Awesome. Thank you so much. See you in the next lesson. Another thing I wanted to go over in this week is parametric UVs. And you may not know what these are, but they are essentially implicit UVs that exist on every primitive in Houdini, or many of the primitives in Houdini. They exist on curves, and they exist on regular polygons. And there are certain functions inside of Houdini. For example, attribute interpolate, I believe. You can use parametric UVs for this specific SOP, and many of the functions in Houdini, like, for example, PrimUV and XYZ dist, both use parametric UVs. But I think it's important for you to be able to visualize parametric UVs because oftentimes when troubleshooting things with PrimUV and XYZ dist and attribute interpolate, it may be beneficial for you to understand where they're coming from, because you don't even need to have a UV attribute on your geometry for these things to exist, because Houdini has them implicitly on most primitives. So how would we find parametric UVs? Well, there's not really an easy way to do it, but let's check out a pig head. And let's go ahead and loop over each primitive. And let's just sample an XYZ dist. Let's build it outside of, let's do it on one. Okay. So we're going to use the XYZ dist function, which let's take a look at. Oh, actually, it probably should be better to do this. All right, so the XYZ dist function finds the distance from a point to the closest location on the surface geometry. And it has these optional arguments, prim and uv, that we're going to extract. And this uv is a parametric UV. So you don't need to have any UVs on this object. Let's check. Let's just remove the shader. And it has UVs still, so we're just going to go ahead and attribute delete these UVs. Just to give you an example of the quality of it not having UVs beforehand. And first, let's create a prim integer for the prim number and a vector param uv, and let's do float dist equals xyd dist, sample from itself, its own position. Let's give it those optional arguments, so prim and param uv, and for max dist we'll put 1000. And then let's create an attribute called param uv, and it was stored in this optional attribute param uv, so it's just going to be param uv. All right. So now let's visualize param uv. So you can see how each primitive has its own UV coordinate system. And this is implicit on most polygons in Houdini, so you can trust that it's always there. And even on curves. So let's check out curves. There you go. These are the param UVs. Now this is not the same as using a distance along curve normalization method, because you can distort this. And if you get the distance and you normalize along the distance, then it won't be distorted. And why is this important? Well, that's going to be for the next topic, which is, what if we wanted some points to be sliding along the curve? And we're going to use all of these methods. First, we're going to create our curve and add some curve U to it. One way to do it is to take advantage of the attribute interpolate SOP, because when we scatter points onto this curve, you'll notice there's a prim num and prim UVW attribute. So if you add these will actually fill in the blanks already. You already have your source prim and your prim UV. The source prim will always be 0 because there's only one primitive in this curve, but the prim UV will be that UV coordinate that we just looked at on the curve that's generated by parametric UVs. So now, if we drop an attribute interpolate down, and we fill in source prim and source prim UV, nothing will happen because we haven't done anything to the UVs. This is putting the point, we're interpolating position, so we could just do P, along the prim UV on this primitive. But something we could do if we wanted these points to start moving along this curve is we could artificially, after having sampled where it is on prim UV, add numbers to it, or an offset. So at source prim UV plus equals offset. So now as we move the slider, you can see that they're all moving because we're telling it that it has a different UV coordinate than what it was sampled from, and then it's interpolating position based on those UV coordinates. And all right. So just to extend what we had just done with XYZ disk and stuff, what you could also do if you wanted to do a different way is just use the prim UV function. So we would do our position equals prim UV, and just want to show you what this function looks like. Prim UV geometry, attribute name position, it would be P, prim num, and UVW. UVW is that parametric UV attribute that we generated from the scatter and that we're offsetting in this wrangle. And prim num is this attribute right here, source prim. So it would be prim UV 1, because we're sampling from this line. Attribute name is position. Prim num is at prim num. And UVW is at source prim UV. And I think I got the name wrong on the other one too. It is source prim, yep. Now we have the exact same setup. And you might be wondering, what if I wanted to give my own UV attribute? Because you can't use prim UV because it's going to be comparing this UV attribute to the parametric UVs. So I could change this to whatever UV attribute I wanted to, but it's always going to be looking at the actual parametric UVs of this first input. It'll never sample from whatever UVs I created up here. And for that, all you have to do is use UV sample instead. I think there might be a couple extra arguments. So yeah, UV adder name, which is the UV on this geometry. So in this case, I'm just going to use UV. And it should be the exact same. Yep. So there you go. You've got 3 ways to crack an egg. Attribute interpolate, prim UV, and UV sample for sliding points. And let's just say we wanted to offset this based on time. But we wanted it to keep looping. We could actually use the modulus function we had learned about earlier to do that. Because all we have to do is source prim UV equals well, we could try this. Plus equals offset %1. It only kind of works because you can see that it just repeats. But what we could do also there we go. So now it infinitely loops because we could just modulus the source prim UV attribute after it's been added, after the offset's been added in. And that'll give you this looping animation. You can even do different speeds if you want per particle. So you can do a lot of different really cool things with this, but this is the base setup. Okay, so we've gone over some really cool concepts, and I think we should end the week by trying an example or two, just to kind of get the creative juices flowing and see how you can layer some of these effects into your work and to create different looks. So I was looking through ArtStation, and I found this concept right here for, I think it was like some Harry Potter stuff by Sarah Carmody. I thought it was really good. The contrast is like super interesting, and it's kind of like this like dark magic feel to it. And just to break it down a little bit, we've got like a couple of lines, energetic lines going through this kind of dark volumetric field, and some particles. So we'll take inspiration from this. We're not going to do the exact thing, but let's try to make something. And I also like the way that this is kind of like a look, because it starts and ends within the frame. It's not like, we're not going to put this in any kind of shot context. We're just going to try to make something that kind of feels self-contained, and that you could get an idea of what an effect might look like. Let's drop down a geometry node, and we'll call this, I don't know, dark magic. And let's just start with a line. Actually, I'm just going to create a curve myself. Now that I think about it, maybe we start with a camera. So let's create a camera. And let's call this guy RenCam. And I'm going to zero out everything. except for Z. Maybe a little bit of Y. Just mess with Z until I see what I'm looking for. There we go. Something like that. And I'm going to make this 1920 by 1080. Actually, I'll make it 1920 by 823, which is like, I don't know if it's exactly the resolution for 2:4:1, but it's pretty close. All right, so now let's dive in and grab a curve. And I'm just going to create a curve that, for the most part, is straight, but has a little bit of a curve to it. And I'll resample that, make it a little bit smoother. Still kind of sharp right there. Not really sure that's not working. It's kind of hard to see as well. So I'm just going to guides, point marker size. There we go. Just couple of these together. There we go. All right, so that looks pretty good. So let's go ahead and make our curve view. And the first thing I want to do is make some of those twisting curves, but we want it to start close on the end and then end up, or start close on the starting point of the line and then end close to the ending point of the line. So let's go into our twirl around setup. I'll just grab this whole thing, plop it down here. And let's figure out why this isn't working. Oh, we need to drop our orient along curve right here. And I'm getting out and in, so let's do that. There we go. Calm this down. All right. So let's get a good amount of twist in here. And that looks pretty good. Something like that. There's that weird kink. I'm gonna just offset it out. All right. Two of these guys. Oh, and then let's go ahead and do the pinching at the end and the start. So the way we could do that is just by going to our multiplier here, and multiplying this, let's do a new float called weight along curve, or let's say curve weight equals ramp curve weight. Actually, for just because naming I think is important when you're revisiting things, let's just call this pinch, and call this pinch, and remap curve view. And we'll then multiply these together. So it'll multiply it out, it'll multiply it by the mult that we have down here, and then it will also multiply it by this pinch, which if we weight it, so that it's high in the middle, and then at the end it goes back low, you can see now we're getting that like kind of pinching motion, and we can play around with this a little bit more. Like, let's check this reference, and I think that should be okay for now. And I actually want to go ahead and like put a little bit more noise, like just general noise, on the line beforehand. And let's try this first, and then we may have to adjust this and put this in a VOP. I really don't want any roughness either, because I don't want this to add any visual detail. I just want this to want to shape it a little bit more. So if we now animate this, let's see what that looks like. So that looks kind of weird. I don't really like how like these endpoints are moving. So something I could do is go up to, where is like amplitude? I can't remember. Amplitude. So I don't know why that, it's kind of a bummer that that this doesn't have a use of expression, but I think I can use this. Okay, so I can only do these guys. So first of all, let's not animate the noise here. Let's animate it here, because I think I can do offset dot x plus equals at time divided by 30. And that's going to move it more directly this way. So maybe let's make it a little bit less so that it's faster. It's not really that fast. So let's multiply this by like 3. I don't know. There we go. But let's actually do like, I don't know, 1.5. That was a little too fast. Yeah, I like that. That's kind of nice. And so we wouldn't really want to keep this starting point anchored. Let me just see if I can do this in here. We may have to jump into a point VOP. Yeah, so I think we're gonna have to jump to a point VOP, which is fine. So let's go ahead and just redo this in a point VOP. Let's call this add noise. Let's add some AA noise. Fit that AA noise. Let's do 3D noise, and then let's do the point -0.5, -0.5, -0.5, and let's do -1 for all of this. And let's add this guy. To this. Let's play around with our settings. Let's go back for that roughness. Maybe amplitude will go down. Frequency, let's just parent. Let's create copy parameter and paste relative reference. And let's just play around with this a little bit. So for this noise, something I'm noticing is that it's looping back around. And I, like, we said earlier, for this type of noise, I don't want that. So let's go ahead and use our vector rejection or vector align node that we had to do the input vector. And then let's do the target vector as n, since we did the orient along curve, and n is our tangent. And then let's subtract from this, and then add this guy, whoops, in here. Okay. So now we can play around with our noise and not have those loop-de-loops. Yeah, I don't really want like any details, so I think we're just gonna leave that kind of as is. And then I really want it to be like really broad, something like that. So now let's grab time. Let's do float to vector. And I pretty much only want to adjust the X offset. So let's just cancel that guy out, vector offset. So now you can see it's just moving. Well, let's try like, try a couple other ones. Yeah, that's the one. Yeah. I did stupid. All right, so now let's do let's ramp. And what we want to ramp is curve U again. And for this magic thing, I'm not really concerned about where the ending point goes, but I do want the starting point, like where the wand might be for Harry Potter or something, or the source of the magic to be anchored. So something I can do is just ramp this, and we'll make this a spline ramp, and multiply. Let's just take this whole thing over here. Multiply this guy. This ramp. And our ramp's right here. Let's just do this. B-spline, B-spline. So now we have let's just make sure. Yeah, we have the wrong one. So something that happens with curve view all the time is that it's just like in the wrong orientation. So you can just drop down a reverse beforehand. I think that does it. Yeah. So now we've got this line kind of animating out. Maybe let's make it a little bit faster. So let's mult constant. Let's make it like 2. And maybe we'll make the frequency a little bit lower. And let's see what our curve looks like. It's kind of cool. So let's go ahead and make a few more of these and vary them up a bit. So let's grab our iteration again. And let's go to our offset. And let's multiply this by 10 maybe. That's kind of neat. And then maybe let's, so what is our offset? It's 20. Let's go back to our offset area, so this guy. And maybe what we do is add our own custom thing, like a rand, let's do a speed multiplier. So I'll just do this as a separate thing, but let's do curve view. Actually, yeah. Let's just make a custom float for offset. And let's move this guy in here. And let's multiply him randomly from the, let's call this like, say iteration. So let's randomly multiply, or let's randomly get a number for each iteration. And let's fit that between, let's say, 0.5 and 2. And let's change this to offset. And then for iter, we're just going to grab this guy and put him here. So now it's just a little bit more random. Let's take a look at our effect again. So now we want to add some kind of animation going in this direction. So the way we could do that, well, actually, let's quickly just check maybe adding some more of these, maybe. It's pretty cool. All right. So now let's make some anim. Let's take our anim setup. And let's grab this guy here. Put him here. And we don't have age or life. So what we could do is we could just make a age and life for each strand. And since we have our strand ID, this shouldn't be too hard. So we've got strand ID. So let's do float age equals fit, and let's get age in. Let's just go ahead and get a norm age. Like we actually don't need to do age in life. We just need norm age, which is just a 0 to 1 float. So it's kind of like our ramp bounds, I suppose. So let's do like at norm age. Actually, let's do float min frame equals fit at frame, or fit rand. Let's do fit 0 1 rand, and then let's do at strand ID And let's do that between 1,000. Let's just do 1,000 and 1,100 just to make it nice and simple. So it's going to randomly pick one of these frames to be the minimum frame. Let's actually do 1020 for now, just to make it a nicer example. And then let's do a float life. Let's just pretend we have a life, and we're gonna do the exact same thing. But this is gonna be how many frames it lasts. And let's also remember whenever we have like two different rands, we want to go ahead and make add some random seed to it. And then the life in frames, let's say, is between 10 and 30 frames. So at norm age would be fitting at frame between min life or min frame and min frame plus life between 0 and 1. So now when we come over here, let's just call norm age at norm age. And now let's just check to see what we got right off the bat with anim. Okay, that's cool. I think we can do better. So let's make the width parameter. And let's also go ahead and make this. I like to have these as colors because it's just easier to visualize. Let's make width a little bit longer. Not 1, but maybe like 0.5. Okay, so that's cool. But you see how they all stop right there? Okay, so the way we could fix that is actually just to go to norm age and fit norm age between, or fit 0 and 1 norm age since it's 0 to 1 already. And fit that between 0 minus width and 0 plus width. And 1 plus width, sorry. So we're going to have to change the order of how this happens. We're fitting norm age from 0 to 1 to 0 minus width and 1 plus width. Okay, I think this needs to happen after we ramp. Yeah, okay. Now we're back on track. So now we've got all these guys, but I want it to be going throughout the whole thing, right? And so one other thing we could do is just make a ton of them. So right now we've got 6, but let's try 20. And then let's also, for each of these rotates, let's add another randomize multiplier. So let's do rand. Let's do fit 0, 1, rand at, which one was it? Iter plus 3. And then let's do 0.23. Sorry, that's supposed to be times. And let's make it maybe like 0.2 and 2. Still kind of large. Let's do like 1.3. And let's make this like 1. And then as we can see, we're going to get all this really cool kind of animation stuff going. But now let's go ahead and make this actually back to its original range, so 1100. So just throughout the entire range of the shot. And now we just have these guys animating, you know, every so often, right? And maybe we want more animation than that, so like we could just increase the amount of strands to like 50 or something. And then what we can do is let's just visualize, because it's getting a little hard to see what's going on. But what we can do is just pipe this into the alpha. And now we can see what's going on. So some of these guys are going pretty fast, I think. Actually, I think that's probably okay. But yeah, I think that's all right. So now that we've got our main strands, let's go ahead and make a couple of extra attributes like width as well. So let's do at width. So at anim, let's fit 0, 1, at anim 0. And let's do like 0.1, I think. And a little trick about Houdini that I don't know if you knew, but you can go to geometry, shade open curves, and make sure that's checked. And then you won't see anything in the viewport, but if you go to the geometry node under MISC and check shade open curves and viewport, then you can see all the thickness. So let's go ahead and make this much thinner, like 0.01. Maybe even a little bit thicker than that. Yeah, I think that's pretty good. And then let's also ramp this. So just wrap this up in tramp with 0, 1. And then let's play around with this. And our anim right now is just kind of even. So I think for magic, sometimes it's more weighted towards the front. And I think in this case, we might need to just switch it up. Yeah. So now you get like this nice leading edge. And let's just go ahead and make this a little bit thicker. Yeah, I think that's pretty cool. And maybe we make like kind of a central, just make sure we've got like a central beam that's like much thicker. So let's just call this guy, this middle strand. Let's just keep this guy in. And just, well, let's do down here. And let's go ahead and give him a width real quick. A width and an alpha. So let's just copy this. And for fit01, just so we don't have to change very much code, we can just do that and this. There you go. So now we've got a central beam. Yeah, pretty sweet. So I think that takes care of like the general motion of this, but something that, well, first of all, I just think that we need more width, actually, just looking back at this. You know what? I just realized I had this in the wrong area. So I need to do at anim, and then I need to fit this between 0 and 0.1. So now we can mess with this a little bit more. And let's just make it 0.05. 0.03. Cool. That looks pretty good. Let's go with 0.02 actually. I still think some of them are going a little bit too fast. So let's go find where our speed multiplier is. Which is here, because it's going to be the live is the speed here. So let's make some of them live for 20 frames, and then let's do 40 frames. Yeah, that looks pretty cool. And then let me just look back at this reference real quick, and let's find out some other cool things we could do. So something I'm also noticing is that each of these guys are actually just much thicker. So, but they're thicker along the line. So we could just add some noise to the, like some overall stationary noise to the width. So we could just do like an attrib noise and make it a multiplication. And let's make it width. So now you can see there's a little bit of variation in the width. I can make it even more pronounced. Maybe let's increase the roughness a bit. Maybe something like that. And just playing around with some of these parameters and getting like a nice good look in there. That's a little bit crazy. You know, we don't really have a ton of points. So, you know, your mileage may vary. It's kind of a neat angle. All right, so now what could we do? I think it'd be kind of neat to see some of these lines kind of like fade in and fade out. So let's go ahead and copy over our modulus operator. This guy here. So the first thing we need to do is let's make this time increment Actually, just a fit 0, 1 of rand at strand ID, say plus 30. Let's make it like 1.5 to 4 seconds. And that looks fine. What do we want to do with pulse? Let's just multiply color by, or let's add pulse. So you can add that. Oh, actually, let's do it to the alpha. Just kind of seeing what we can get. Kind of want to see what this is doing without the animation. Maybe let's make it like 1 and 2. Oops. All right, so also we want this to kind of, fade in and out. So let's just remap this. So now you can see it's actually fading in and out, but it's not very smooth. So let's tweak with this a little bit more. It's kind of cool. I just want something really subtle. So that should be fine. So let's go ahead and add this back over here. And let's just do times equals pulse. So we're just layering different, elements in here and just adding complexity, and you can tweak these to, however you want them. And now I kind of want to add some noise. So what we could do is we could just copy this, add noise that we did that was a kind of a broader noise, and let's make some finer adjustments. And before we do that, let's drop down another orient along curve so we get all of our new orientations. And then I'm going to go ahead and drastically increase our frequencies and reduce our overall amplitude. And then I want to multiply this quite a lot. Let's do like, that looks kind of cool, but I think ultimately it looks a little bit static. And this one actually looks kind of neat. Kind of gives like a jittery feeling to it. That looks pretty nice. But if we wanted to break this up a bit more, we could also just bind in strand ID as an integer, and then randomize that integer with a 1D output. So that'll give us a float between 0 and 1, and we can fit that 0 to 1 float to, let's say, 5 and 15. and then multiply this by this, disable this guy. And now we've got a bunch of different speeds that this noise is animating. But it's all moving in this general direction. We want to give it some directionality still. Yeah, that's pretty cool. All right. Let's see what else. So we can also grab, let's go check this reference out one more time. There's a lot of points in like kind of thicker lines and energy and stuff, and so we want to add a little bit of that kind of feel to it. I think overall these lines could be thicker. So let's just make this like double. Cool. And so let's go ahead and make our colors. I think that'll be a good thing to do. So let's go ahead and drop down a noise. In fact, actually, I'll probably just grab a lot of this setup. So I'm just going to copy this guy. Call this color. And the first thing I want to do is just a base of some general color. Just delete all this. Delete all this. And let's just make it a color. And let's delete this guy. Actually, keep them. For some reason, this isn't displaying. I think it's just being melted down quite a bit. This might be just a viewport thing. So let's just close this guy, make a new scene view. Yeah, it is. And let's power this guy up. So exponent, let's go ahead and square it just for now. And then multiply, add constant. Let's make it like 10 times as bright, maybe 20. And then let's ramp this. And just make like a fun ramp. Let's take a look at the colors from the reference. So it's got some dark blues, some purple, so let's just play around with this a little bit. switch where this is because right. It's a little bit too blue. Maybe this a little bit more purplish. And this I feel like is a little too bright. And let's go ahead and play. Let's just tweak with all this stuff. So I'm going to tweak, and then I'll kind of come back at the end and show you kind of what I did, and we'll go from there. All right. So this is what I came up with. I think it turned out pretty good, and you know, in terms of the reference, it definitely strayed a bit, but something. I think it definitely has like some kind of relevance to it, at least. It's kind of interesting what I was playing around with color and kind of what it could do to it. Like this one looks very mystical, and then this looks very like kind of sinister or evil, like maybe some kind of villain would have it. So yeah, playing around with color is definitely a big one. I like how there's like some variation in like whites and then pinks and then blues and purples, and then this one's a little bit more monochrome. Maybe that's why this looks a little bit more mystical, like there's more intrigue. But I also rendered out just a different curve to show you guys that, you know, doing things in a way like this procedurally that really promotes like being able to put in whatever input. Like I didn't really change very much on this. I think maybe I increased the amount of twists, but didn't really do very much. So from a production standpoint, it's, you know, if you can do things like this, it really helps getting through some shot work quicker. And if you hand it to other people or if you run it automatically, then maybe it's just a little bit easier to work with. So I just want to quickly show you the setup because I mean I did add this volumetric element and some of these points. So I just wanted to quickly jump in and show you what I did for that. We're not really going to cover the rendering in this week, but if you are looking for things to do and you've already gotten through all the setups, then you could try rendering something like this and just playing around with different ways that this could animate. Like, just to give you some ideas, these lines are very organic and they're very smooth. Like maybe you could make them more jagged, electric, and kind of a little bit more aggressive. Like this is very, I would say, fantasy and less kind of sci-fi. So maybe you could try to figure out ways of making this a little bit more sci-fi. Not really sure how you do it, but something to consider. And then play around with any other parameters that you just kind of are curious about. Like I think this week it's less about getting something to work with and more about just getting familiar with the concepts. So don't worry too much about rendering, but you know, I think this is like kind of a neat effect to get under your belt because it's just a little bit more abstract. And then also for the smoke stuff, like this is not simmed, and I would try to stay away from sims for this week, just because I think the point of the concepts I'm trying to show is like what you can do without any solvers or simulation. So just to let you know, the I'm not trying to hide anything, that I rendered the volume with Arnold, and then I rendered the lines with Mantra. And I'm gonna go through the actual settings of these in later classes on the electricity. But I just did 2 passes, and then did a pretty basic comp in Nuke for this. And I would also always suggest that you make a render object, just because when we set up our ROPs, especially when we have multiple passes, it can be incredibly cumbersome to like have to remember to put your display flag. It's just not a very good way of working. So I would always split out your render objects, and it could be as simple as just having an object merge. In fact, I would recommend not doing anything in these, because you're going to forget about it, and you're going to wonder why things look a certain way. So just be careful about that. In fact, sometimes I even just make them red, and you'll see that in my project files. The other thing that I also like to do is, I don't really use transforms on the object level. I think they're useful in some cases, but for me, it just becomes more confusing, especially when doing more effects related stuff in SOP land. So I tend to try to leave these all zeroed out, and because I do that, I like to use these inputs and connections just to show relevance. So if I've got this setup here that produces a volume, a curves, and a points pass, which, by the way, we're not using this points pass, then I'll connect them up just so that if anybody's looking at my project file, they can say, okay, well, so the work's being done in here, and it's producing these. But that's just a way I like to work. But I'm sure that that's depending on what you're doing on object level, it may not be that smart to work that way. So in the last lesson, we had made this, which was just, let me just hook back up our original curve. We had made this, which was just all of this stuff rendering, or just all this stuff kind of animating in this way. And what I did was I duplicated the internals of this over, because I saw that actually in our reference. Hold on, sorry. In our reference, there was some tendrils down at the bottom that I really liked, that were a little bit separate from the rest of them. So this is just making one where all I did was I pinched it a little bit different. My ramp here is different. Pinched it up in at the start of the curve so that it's really active and twirling around in the start of the curve, and then towards the end it really simmers down. So this one will add some really nice detail up at the start. And I just copied these over, and that's about it for this. Oh, and I also just adjusted so that this animates like all the time. Let me see real quick. So for norm age, I used our modulus operator, and all I did was I fit a random. Obviously, we've got our strand ID right here. So for this, I just had a random value for the strand ID between 0.4 and 2, and then my norm age was time modulo time increment, so that it will just loop on this time increment. So which is somewhere between 0.4 and 2. So I can just show you that real quick. So you can see it just loops. And so for the volume, so now you get this like nice little pop of detail at the beginning every once in a while. So let's go back to the volumes. So the volumes, I just duplicated this over again, and twisted it a bunch more, and created a couple of random attributes like p-scale and density, and I did a different density for each strand. So I just fit a random strand ID between 0 and 15, but I ramped it as well so that I could essentially say that only, a very small amount, you can see it right here, only a very small amount actually get up to 15. The rest are really low. So the majority of them, like this is like a distribution map. So the majority of them are going to be close to 0, and then a couple of them are going to be up at 15. And then this extra ramp that I did was just multiplying the density down at the ends, because we wanted a good transition between that solid point of where it emits and ends, and so that's right here. And then I just added a little bit more noise. This is just duplicating over this add noise right here. And I resampled it a bunch and then rasterized this into a volume. And just to make things simpler, because there's a couple different ways we could do it, but I just dropped in a cloud noise and tinkered with it until it looked decent and had enough detail. Sorry, my dog was barking. So after the cloud noise, after just tinkering with that, I think this is primarily at default settings. I just think I just adjusted the amplitude. I added a volume noise fog, which is new in H19, and just played around with that. I really just wanted some really dense areas and some really not dense areas. So I wanted it to drop off to 0 so that we could see completely the lines. So I think I did like a min value of 0.8 or negative 0.8, and then a max value of 1.2. And this offset is just time. And I animated the noise. Just tinkering around with it. That's like the name of the game, is just kind of finding. And like, if you're not familiar with this stuff, like you will be relatively quickly. I think it's just about tinkering around, see what happens. I made the roughness really high. So you can see like what that does. It just makes it a little bit more detailed. And that's about it. And then because I went to my min value is negative 0.8, I went ahead and clamped my density between 0 and 10 because we don't want any negative values in there. I'm not sure if it does anything weird, but I try not to do I try not to do anything that might throw off shading later, even if it's not completely necessary. And then I just multed the density up by 10. It was just while I was shading, I found that I wanted to mult it up a little bit before its output. And so this is kind of where the interesting part happens, which is that we've got our lines before our color, and I duplicated over our color, and I remapped it a little bit because I wanted it to be a little bit more desaturated, because ultimately when light is really bright in the scene, with cameras it goes to white because it starts clipping colors, but in CG what tends to happen is that it gets really super saturated. And while that's kind of unavoidable, I think desaturating what we're going to use as our emission is pretty valuable. So all I did was I went into these colors and I just desaturated them a little bit. I think I moved it a little bit this way. So that's all I did. And then I added a p-scale noise just to give it a little bit more variation. Resampled it similar to how we did with the volume up there. And this one, all I did was I did a little something to the color. I cubed it, so this pow is an exponent, so it's just to the third power, and that gives it a little more contrast. Multiplied it by some number that I just thought was good at the time, so 8, and then I fit anim between 0.01 and 1. And the reason I did that was because this emission is going to be essentially 1 where anim is 1 and 0 where atom is 0. But I actually wanted a little bit of these lines to be emitting even when atom was 0. So I made it 0.01 just to give it a little bit of emission, which I think helped the volume out. And then I rasterized that, and I rasterized emission and vel. So vel is just the normal tangent, and then I also added v, which is also the normal tangent, so that I could velocity blur it, which just helps make it a little bit more smooth. And I merged them. I haven't really played around with the Pyro Bake Volume node yet, but I was just kind of messing around with it, and I just thought I was getting some kind of interesting results. But just something to maybe play around with. There's just an endless amount of things to play around with, so kind of just tinkering around until you find something that is cool enough to try rendering is kind of the name of the game. And that kind of, especially if you have a reference that you're keeping to, then you want to try to match that look, obviously. So then that's the volume. It just has density, emission, and vel. And vel is like not even that necessary, to be honest, because this is so abstract. Like, it kind of, velocity is whatever you want it to be, or whatever looks correct. I would always start like with the real values, but you can veer from them if it doesn't look right, So just keep that in mind. So the other thing that I did was I duplicated it again, and so I have this, and this is just probably about the same as this in terms of amplitude of curve out. I time shifted that just to frame 1000 and scattered, because I really want like a very constant scatter. And I actually like using this a little bit more than the UV stuff, because I feel like I can control this a little bit better. And then I just point deformed it back to this. So you just keep your mesh to deform as your time shifted one, your rest as time shift without the scatter, and then your deformed as the target curves. And it does a pretty good job. I mean, if we look at this, you can see it's pretty much where it needs to be. So, and then this attribute interpolate. This whole setup, by the way, is what we did in the previous lesson in relation to points along curve. So it's this part right here is what we're using, and that's kind of why I said it was kind of important to build these setups, because we're going to use these a lot, and you can just come and copy and paste them. And then I just did I appended a trail so that we get all of the correct velocities going along this. And you see how there's like these crazy velocities. That's because at the end of this, our point, since they're looping, and the setup we did, they snap back to the origin, and that creates a really long velocity vector. And we can just, there's a couple different ways we could do it, but just for the sake of doing it quickly as we're iterating, I just removed really long velocities and really short velocities as well. So you get all of the correct velocities, which is nice. And and I also added a attrib randomized p-scale set to exponential distribution, which I usually tend to like the most. I think it's like the most natural distribution choice for floats. And then you just set a min and max limit and play with the middle value until you get something that has a good amount of occasionally a large one, and then a bunch of small ones too. And just kind of, you want to tune it to your eye. So I thought this was a decent distribution. And that's about it. So at the rendering level I'll just show you the volume setup, because the other ones are pretty simple, even though we're going to go over these later. For the volume, all I did was I added a standard volume shader for Arnold, and I went down to this emission, and I set our emission channel to emission and mode to density, and I just played around with this value and found something that I liked. So something like looks like this maybe might be nice. You can get a lot of different cool results with it. So just play around with it, and that's kind of the whole idea of this first week, which is just get familiar with everything, some of those techniques that we were talking about, and just have fun trying to combine them in different ways. And this is kind of like a fun exercise that you could try if you have time. And as always, you can revisit it later if you need to go over it again, or if you didn't have time. So just have fun with it. And let me know if there's any other questions for this.